Game na ya. Good afternoon, sir. Good afternoon, classmates. I am Marisol Ayodulio and I am the first presenter sa aming group po. Next slide po. Okay, our topic po is all about protecting steel superstructures with my group mates, Ms. Marian Puda and Mr. John Nico Reyes. Okay, so yes po, next. Okay, so ano nga po ba yung protecting steel superstructure? So far, we have discussed this is the design of steel highway bridges with a focus on the analytical aspects of the design process. And of equal importance, however, is the specification of systems designed to protect the steel superstructure after its construction. Whether it is the use of paint system or weathering steel, in today's design environment, engineers are becoming increasingly aware of the importance of ensuring the longevity of the structure they design. Next page po. Okay, so to many designers, the application of a protective coating to a steel superstructure may almost be an afterthought. There is an obvious need to protect an exposed steel superstructure against the corrosive aspects of natural and man-made elements. In the minds of many engineers, both young and old, the specification of a paint system would seem to be a simple boilerplate operation. As we will see, however, the advanced state of deterioration of many steel structures combined with the heightened awareness of the environmental impact of many protective systems has led to the protection of steel superstructures becoming a prime issue for many transportation agencies. Next page po. So the following discussion will focus sa ating two majors of protecting steel superstructure. So kung paano natin mapoprotektahan yung ating steel superstructure. So una, protective coating system, at yung pangalawa naman ay weathering steel. So we'll also look at the important issue of paint removal and the impact it has on the rehabilitation of existing structures. Next page po. So yun, sa protective coating system natin, isa sa mga arguments proponents ng concrete bridges na ginagamit sa lobbying against steel structure is susceptibility of steel to corrosion from the elements. So, incorporation can and reducing maintenance costs in the future. Obviously, the paint coating used by transportation agencies did not evolve overnight, but agencies and refined and modified as a result of their use and performance. Prior to discussing the main coating system in use today, an investigation into the origins of the system is beneficial. Next page po. So, yun. So, background and history ng ating protective coating system. Ang origin of the modern protective coating system can be traced back to the middle 19th century. A prime example of how protective coating systems have developed can be found in the Perth to Fort Bridge in Scotland. The Fort Bridge was first opened in traffic in 18. The system or the paint system applied to the structure bears a striking similarity to those present in many bridges still in use today. Service limit states its elastic section properties should be used for all composite and non-composite sections. For steel bridges, the objective of the service limit state is to avoid the steel from yielding under normal load conditions, therefore, to avoid permanent plastic deflections. Next page po. Okay, so ano ba yung nature naman ng steel corrosion? So, like the corrosion of reinforced concrete, corrosion of steel is different metals are placed in an electrolyte and electrical current is created between the two metals. An example of an electrolyte would be salt. In essence, one metal acts as the anode and the other as the cathode, with deterioration being the end result. This process of deterioration is known as galvanic corrosion. Whether or not a particular steel structure is more susceptible to corrosion than another is dependent on many factors. The presence of an electrolyte like salt water, is it through basing agents, or a marine environment can greatly accelerate the deterioration of steel structures. Other factors which can accelerate corrosion are the presence of carbon dioxide and hydrogen sulfide, as well as extremely high temperatures. Next slide po. Okay, so ano naman yung inhibitive primers niya? A primer is the initial coat of paint which is applied to the virgin surface of a steel member. The quality of a primer is indicated by its ability to adhere to the surface of the steel. An inhibitive primer functions through use of an organic coating which stops corrosion through a process of chemical or mechanical inhibition. This inhibition is designed to prevent deterioration caused by moisture and oxygen. The pigments of inhibitive primers give the coating their inhibitive characteristics. A pigment, by definition, is a fine, insoluble powder which is dispersed into the liquid portion of the paint. The pigment gives the paints its color, hardness, and corrosion-resisting properties, and can be either organic or inorganic. There are two basic types of pigments used in inhibitive primers: soluble hexavalent chromium salt at yung basic lead compounds. Next page po. Next page po. Okay, so sa sacrificial primers naman natin, like an anode in an cathodic protection system, a sacrificial or galvanic primer protects the underlying steel surface by creating a surface which is electrochemically negative in relation to the steel, rendering completely cathodic and eliminating potential deterioration. Zinc is the most common material used to make the primer act as an anode. The zinc is dispersed through the paint film as a pigment and applied directly to the steel surface. For continuous span bridges, the negative bending regions can either be designed as a composite section or a non-composite section. The convex deck is in tension, so it will be ignored. The reinforcing section is also ignored if a non-composite section is assumed in the design. If the section is assumed as the composite section, then the reinforcing steel on the deck can be considered as part of the composite section. Next page po. Okay, so yung barrier coatings naman natin, ito yung design para ma-prevent niya yung water, oxygen, and ionic material from coming in contact with the underlying steel surface. The system is typically composed of multiple layers of essentially the same substance. Types of barrier system coatings are coal tar enamels, low-build vinyl lacquers, epoxy and aliphatic urethanes, and coal tar exposés. While the thickness of coats used in barrier systems is often insufficient in preventing moistures and oxygen from precipitating the cathodic reaction which causes deterioration, the system has proven reliable in protecting superstructures. The reason for this is the ionic impermeability of the barrier systems. Even though moisture gets through the barrier, it is usually of such high electrical resistance that the cathodic reaction from cathode to anode is minimal. Next slide po. Okay, so sa overcoating naman, ang method daw na pag-apply na to ay nag-exist sa steel bridges, which is based on the stop cleaning approach. Is known as overcoating. Under the overcoating approach, corroded areas are cleaned using hand or power tools to remove broken down paint, loose brass, and old coatings. The entire steel, regardless sa condition niya, receives a thorough cleaning through a use of a powder water wash which removes dirt, and a certain percentage of chlorides, which are embedded into the surface of the steel. Once the steel surface is prepared, as described above, a three-step painting process is conducted where any exposed steel areas are spot primed with a surface tolerant, one component moisture cure polyurethane aluminum primer. A polyurethane immediate coat is applied to the entire bridge surface, and a light staple polyurethane top coating. So, micaceous iron oxide or IMO coatings. IMO coatings have been called Europe's best kept secret. The success of MIO coatings on such prominent European structures as the Eiffel and the Royal Albert Bridge, as well as the Disney Harbour Bridge in Australia, had led to MIO becoming a de facto standard for bridges overseas. In US, however, only the Virginia Department of Transportation has used MIO coatings. Next page po. So, sa conclusion, by now, the reader should have a feeling as to the basic types of protective coating system in use and the various methods of preparing the steel components on which they are applied. The issue becomes even more complicated by certain types of coatings being combined with other to form a composite system. And that would be all for my presentation po. Let us now proceed to Miss Marian Puda. Um, the floor is yours po.
Good afternoon. My name is Marin Tuda and I am the next presenter. So let's continue to the topic containment and disposal of paint waste. First is the background and history. Thousands of miles of highways and thousands of highways bridges began to spring up on drafting tables and into the field almost overnight. Designers of the era gave little or no attention to the removal and disposal of the lead-based coating system that were being applied to this new structure. Next slide. Mid 1960s and the early 1970s. During these years, the environmental movement gained momentum and suddenly engineers found themselves adapting to a very new world. This is not to say that transportation departments themselves did not take the initiative in formulating programs to deal with environment concerns. In early 1960s, states like Louisiana and California had begun to formulate programs which addressed the problems associated with lead and chromate-based paints, as the hazards of lead paint became more fully understood. State agencies sought to tackle the most glaring problem areas, especially the state sought to address the entry of lead particles into streams, adjacent lands, and groundwater supplies. Next page po. So in the early 1980s, only a few transportation agencies were aggressively pursuing the issue of the containment and disposal. In mid-1980s, Transportation Department began to actively study the problem in an effort to develop techniques and guidelines that would help them conform with the new laws while at the same time perform their function, ensuring that the highways, bridges they manage were adequately protected. In late 1980s, manufacturers were also investing research and development dollars into the development of new systems to aid in the containment, recycling, disposal, and processing of the waste. Next page po. So for the the containment devices is required during paint removal operation to confine and collect waste and debris caused by surface preparations. The containment device itself is either an enclosure or barrier which is placed under or attached onto the bridge structure proper. The type of containment device will vary depending on a variety of factors, which could include method of surface preparation, extent of assembly required, and cost. Next page po. While there are no steadfast rules or specifications governing the type of containment device to be used in all instances, the following discussion outlines some of the more basic methods of containing paint waste and debris. Ano yung naka-share screen kayo? Ano yung naka-share screen kayo? Ay, ayan. Ayan. Hindi, number 2 pa lang. Ayan, yan. Ayun lang. While there are no fast rules or specifications governing the types of containment device to be used in all instances, the following discussion outlines some of the more basic methods of containing paint waste and debris. First, free-hanging enclosures. A free-hanging enclosure is typically a tarp or plastic sheet supported on only two corners. Example, tarp pinned at the top of a building deck and left to hang down to the underpass roadway surface. Next slide po. Second, complete structure enclosure. A more extreme alternative to the free-hanging enclosure is to completely enclose the structure. Such an enclosure can be fashioned by using concrete or prefabricated panels. While such a method definitely produces a secure environment within which debris can be contained and eventually disposed, it is not without potential difficulties. For the disadvantage, one difficulty is visibility within the enclosures. The bridge is surrounded by a solid structure, but at the same time, blasting or cleaning operation will be generating large quantities of dust and debris. Proper lighting and protective equipment for the crew is an absolute necessity when a complete structure enclosure is used. Third, circulation of air within the enclosure must also be maintained. Next slide po. Next, the enclosure itself is a structure which must be properly designed to withstand a variety of loads ranging from the workers within it to the wind loads on the outside of it. And last, inside the structure, there must be appropriate facilities to allow workers to get at the bridge itself. In many instances, these platforms will need to be elevated to reach superstructures elements so that appropriate safety concerns must also be addressed here. And for the advantage, the potential for reusing the enclosure components on project. Next, beneficial on large structure where the enclosure unit can be broken down after completion of work at one point on the bridge and reassembled at the next point of work. Next, next is negative pressure containment. A danger with enclosing a structure is the potential risk of dust particles escaping the enclosure. One method of preventing this is to create negative pressure by drawing air from outside the enclosure into the enclosure. The air is passed along the surface being worked on and then passed out of the enclosure through the filter. Next, power tool debris containment. While the debris generated by power tools is more easily contained when compared to blasting methods, containment, and the disposal of paint waste. Next po. Next is collecting pollen, abrasive, and debris. Even with attached vacuum devices like those described above, debris will invariably fall to the ground. When blasting methods are utilized, abrasive will be distributed in the work site and need to be channeled and eventually collected. When dealing with abrasive, irregular collection plan, preferably once per day, should be employed to remove abrasive and waste. Next slide. Number 3. Recycling abrasives. One ecologically sound method of minimizing the waste resulting from surface preparation operation is to recycle abrasive used in blasting methods. Recycling abrasives is accomplished through a two-step process where the abrasives are collecting and then reclaimed to separate out the reusable abrasive. Three principal methods used for separating out the reusable abrasives from the associated paint, dust, and debris. The main system currently being used are: first, air wash separators; second, cyclone separators; and third, rotary vibratory separators. Next, number 4, disposal methods. Disposal of paint and abrasive debris from a project site used to be a relatively easy affair. Spent abrasive was either hauled away to landfills or deposited in rivers. The process of treating the hazardous waste can be conducted to one or two levels. The hazardous waste can be and the non-hazardous waste or converted to a non-hazardous form. The process of disposing of hazardous waste is further complicated and made more expensive by, by regulations which concerns the handling, packaging, storing, transporting, and testing of the waste. Treatment of the waste can be conducted on or off-site by physical or chemical methods, with each having its particular impacts on the overall cost of the process. Next, physical methods. Physical methods entail physically separating out the hazardous component of the generated waste. The principal methods for separating out the hazardous components are screening, crushing or grinding, air wash, flotation, and drying. The physical method used for separating out hazardous components is generally dependent on the nature of the abrasive used during surface preparation. Metallic abrasives lend themselves well to air wash filtration, while non-metallic abrasives may not react well to this process. Next up, chemical methods. Chemical processing of the debris is designed to eliminate the hazardous waste of paint waste through one of two principal methods, which are to either vaporize the lead in the debris, make the lead particles insoluble. The former could involve the use of high temperature incineration, while the latter the addition of Portland cement to the debris. In some instances, the waste is even treated on site, although such an alternative is subject to strict requirements by EPA. Next, number 5 is the conclusion. The apparent simplicity of simply slapping a copper coat of paint on a steel superstructure certainly belies the impact removing, containing, and disposing lead-based system has had on today's transportation agencies. In summary, engineers in maintenance departments are put in the middle of three conflicting needs in that they are required by law to satisfy: environmental safety, worker safety, and safety of traffic over a structure. Next is weathering steel. Weathering steel on the surface, weathering steel would appear to be the answer to the many problems and the costs associated with conventional protective coating systems. reality, which we will see, is not as good as it may first seem, but not as bad as some would think it. The following is the discussion of the basic properties of weathering steel, its benefits, and associated difficulties. First is background and history. Weathering steel was originally developed for use in the fabrication of unpainted coal cars. Its, introduc- its introduction into the world of highways bridges did not occur until the 1960s. The promise which weathering steel held and the initial positive feedback led to its quick incorporation into the standards of many highway transportation departments. One such example is the Michigan Department of Transportation. The state's first weathering steel bridge was built in Detroit in 1963. Performance led to weathering steel being adopted throughout the state in 1969. By the 1970s, over 600 highway bridges were constructed using weathering steel in the state of Michigan. Next, material properties of weathering steel. Weathering steel is a carbon steel based alloyed with roughly 2% of copper, nickel, chromium, and silicon coming in yield strength of 50 to 100 psi. Highway bridge structure typically makes use of ASTM A588 and A709. For the purpose of this discussion, we will refer to weathering steel as ASTM A588. While moisture is essential to form the protective coating, continuous moisture can adversely affect the performance of weathering steel. Some sources of continuous moisture include nightly condensation, cooling from the deck causing moisture to run downward, capillary moisture, absorption by corrosion products, leaking joints, spray from traffic, a high relative humidity, nightly fog, and moisture which evaporates from nearly bodies of water will also spur the development of moisture over the surface. As we will see, these environmental conditions played an important role concerning how weathering steel will perform. Next, number three is the environmental consideration. It becomes readily visible that the environment in which weathering steel is placed plays an important role in how the material will perform. See also the accompanying design perspective. Environments which are too dry do not have the necessary wet-dry cycles required to create a protective oxide coating or patina. Likewise, environments which are too wet or susceptible to continuous moisture will also serve to hinder the development of a sound patina. It means that weathering steel must be used in an environment which is conducive to its inherent materials properties and their benefits. Next, number four is the maintenance of weathering steel. When weathering steel is placed in the right environmental setting, it will perform well, but it will still require limited maintenance. Anyone who has seen a weathering steel structure will no doubt notice that rather unattractive streaks of rust which often stain the light gray surface of the concrete substructure. These rust blemishes often spoil the look of what the otherwise striking finished structures. Staining of the substructures, however, can be prevented by temporarily wrapping piers and abutments throughout construction with heavy gauge polyethylene sheeting. In addition to this protective measure, liquid silicone or epoxy-based coating can be applied to the substructure in order to protect them. Next, the next topic will be continued by the next presenter. Thank you.
Bye. 5. Inspection of weathering steel. When a steel bridge which has been closed during regular biennial inspection, the weathering steel is inspected to check the color and texture of the oxide film. This inspection is undertaken using a hammer and wire brush to ascertain whether the rust on the surface of the steel adheres to the underlying steel or has become debonded. Debonding is evidenced by flaking or of the rust or peeling of in laminar sheets when either banged with a hammer or wire brush. 7. Conclusions. Whenever a material or any other product for that matter holds out the promise of being a cure or solution, it is liable to undergo harsh criticism if it does not perform as expected. Weathering steel can definitely fall into this category. The examples detailed above concerning the states of Maine and Michigan serve to bear this out. The experience of these two transportation departments with weathering steel also serve to illustrate the long-term nature of the problems associated with bridge engineering in general. The, the initial feedback which the Michigan DOT had on the performance of weathering steel was generally positive, leading to its widespread use in the state. It was not until several are designing structures intended to last decades in a harsh environment. No amount of laboratory investigation or analysis can adequately predict how a certain material even design will stand up. Galvanizing. Another method of protecting steel superstructure is by galvanizing the steel components. Galvanization is the process of applying a protective zinc coating to steel or iron to prevent rusting. The most common method is hot dip galvanizing, in which the part is submerged in a bath of hot molten zinc. Overview. Galvanizing steel is a process whereby a protective coating is applied by immersing the steel member in a bath of molten zinc. This process is also known as hot dipping. The coating provides a barrier against oxygen, inhibiting its contact with the metal base while the same time offering cathodic protection against corrosion. For the most part, galvanizing is an option for new steel components only. Most steel can be readily galvanized. Weathering steel, however, is a silicon content of 15% to 0.75% cannot be galvanized. Benefits and drawbacks. Similar to weathering steel, the principal benefit of galvanized steel is its ability to withstand corrosion. The performance of galvanized steel is such that little or no maintenance or painting is required. There are, however, two major drawbacks of galvanizing steel. The first is the galvanizing is an expensive process with the cost of not dipping steel generally more than conventional painting. This imposes a severe limitation on the continuous bridges with large spans legs. Due to limited of galvanizing in highway bridges, there are relatively few galvanizers in business with facilities that can accommodate the large prices. Proponents would argue that the initial cost is offset by saving in maintenance to the road. While such an argument makes sense, conclusion to the reader, it may seem that the preceding discussion has been rather exhaustive. At the onset of the section, it was mentioned that many engineers may tend to trivialize the issue of protecting steel superstructures. If nothing else, this section should serve as an indicator of how serious the problems are confronting a vast majority of the bridge in the United States and throughout the world. There is, however, no single solution to the problem, not MIO, not weathering steel, not galvanizing. None of these coatings or materials can by itself solve the dilemma of how to protect the steel superstructures. When maintaining a highway bridge structure, solutions are not discovered, they evolve. They evolve. In a quote from Arthur Elliott mentioned earlier, it was said that it is probably safe to say that a completely satisfactory deck joint has been designed. One could substitute protecting coat for deck joint and coat would be just valid. Thank you po. That's all po. Thank you po.